Ma'am, no, I couldn't complete it. I started it.
Yeah, at least by the weekend, please try to complete the matter. It may take some time, however, please complete it by the weekend. Okay, so I'm moving to the differential equation context, which I started to discuss last day. So I mentioned about the standard principle. If there is an excess demand, price will go up. Okay, and accordingly, I presented equation number 1. Change in price with respect to change in time, that is a function of excess demand, where a prime greater than 0, which indicates as there is a positive excess demand, price will go up. So some people had, interest about the second order derivative too. However, purposively, I didn't talk about the second order derivative. I talked something about the speed of adjustment, and that we'll be able to capture using the limit. I don't want to bring the second order derivative, d square p by dt square here, because I will first like to concentrate on first order differential equation. I'll not go for the second order differential equation. If explicitly I bring the speed of adjustment in the model, in that case, I have to start with the second order differential equation. So here, we are trying to put the matter in this way. Higher the excess demand, greater will be the speed of increase in the price. Okay, so that is the idea. So, now to derive the time path using this expression, I'll consider a linear function. Here it is a general format. dp by dt is equal to some function of excess demand. So one by one, I'll make the things more formal. I'll consider a linear relation between dp and dt and the excess demand. And in place of d as well as in place of s, I'll bring the linear demand as well as linear supply equations. Okay, so we will like to formalize the matters. We will solve equation number 1 by taking simple linear forms of f dot, simple linear forms of f. Here within the first bracket, dot indicates I have, I am considering an expression here. Okay, so it is not necessary always to write the expression. If within the parenthesis dot means, we are considering the function in this way. And both for the demand and supply equations, we will consider the linear construct. So suppose dp1t by dt. Why I am using p1? Because typically I am talking about x1. So you can make the entire thing dp dt, or d as a function of pt, s as a function of pt, and you can consider the commodity x. So 1 I am using to indicate x1. Actually, I am considering the price of x1. Therefore, for the notational matter, I am bringing 1. It is not necessary that you have to write 1. So suppose dp1t by dt is equal to alpha into d as a function of p1t minus s as a function of p1t, where alpha greater than 0. So instead of f, now I am bringing alpha, where alpha is positive, because f prime is greater than 0. So I need the change in price with respect to change in time should be a positive function of excess demand, positive function of excess demand. So I'm considering alpha to be positive. Now for the d, I consider the expression a bar minus a1 p1t, and for the supply, I consider the equation b bar plus b1 p1t. Both a bar and b bar I'm considering to be positive. A1 and B1, these signs are also positive. So the inverse relationship between price and quantity demanded has been captured by this minus sign, and conventionally the supply curve is positively sloped. So here I am considering the plus sign. coefficient wise, all these A bar, A1, B bar, B1, all these things I am considering to be positive. Any question? Other things okay?
Yes, ma'am.
Would you please let me know whether the file, the presentation is visible or not? Yesterday,
Yes, ma'am.
it's visible perfectly?
Yes, ma'am.
Okay. Okay. There may be some, mistake in notation or sign, therefore I'm using the Word file. So using this, we write equation 1 as follows. So what I'm doing in this first equation, I'm replacing dp1t by a bar minus a1 p1t and replacing s by b bar plus b1 p1t. Okay, so simply I'm doing that. In place of d, put this value, and in place of s, put this value. And then rearranging equation 2 like this, constant terms I'm keeping together, and I'm taking P1T common, so the expression becomes alpha into A bar minus B bar minus A1 plus B1 into P1T, where alpha is greater than 0. So this is equation number 3. Equation 3 is a differential equation and can be solved as follows. Okay, and it is a first order differential equation because I am considering the derivative, first derivative only, dp by dt. If I consider the second derivative, in my expression, I have the second derivative as well as the first derivative, and p, that will be the second order differential equation. Here I have only the first order derivative of dp dt and we have pt. So it is the first order differential equation. Okay, first order differential equation. Equation 3 is a, you can add first order differential equation and may be solved as follows. So I hope you have no problem with respect to question number, with respect to equation number 3. Okay, now to solve the differential equation, we have to find out the particular integral as well as complementary function. So process wise, there is no difference in case of difference and differential equations. However, here the price variable is continuous with respect to time. Therefore, the presentation is a bit different. Here we will not consider pt plus 1 minus pt. Rather, we will consider dp by dt. Okay, so change we will not indicate algebraically. Rather, we will indicate the change using the calculus. Okay, so this is the different. Process wise, the things are similar. We have to calculate pi, we have to calculate complementary function, and then we have to add the pi and the complementary function to get idea about the time path of price, and then we will go for the stability analysis. So structure wise same, however the process is a bit different, or the tool is a bit different because of the nature of the price variable or the nature of the time too. Time is continuous here. So its solution has two components, a particular solution and a complementary function. Particular solution means the equilibrium price, it indicates the particular integral. So it has a particular solution and a complementary function. Let's first derive the particular solution. Since the constant term in 3 is independent of t, the constant term in equation number 3 is alpha into a bar minus b bar. This is independent of t. Let's try P1t is equal to P bar. You can write PE if you like, whatever you like. Let's try P1t is equal to P bar, where P bar is a constant. Let's try P1t is equal to P bar, where P bar is a constant. Now, when P bar is a constant, the derivative dp by dt will be equal to 0. Is it okay, this part?
Yes, ma'am. Ma'am,
Yes.
how could we say PT equals to P bar? Are we considering P bar to be the intertemporal solution?
Yes. One of the solutions it is, not okay. At a particular time point, one of the solution may be the equilibrium solution. This equilibrium is the intertemporal equilibrium. In the same way, as I mentioned, there is process-wise no difference between the differential and the difference equation framework. Only the tool is varying.
Okay, ma'am.
Okay, so I'm considering P1t to be equal to P bar. Okay, intertemporal solution or particular solution. It is a particular solution for P1t. It's a particular value. So if P1t is equal to P bar, I'm telling about this part, whether this is clear to all of you. dP1t by dt will be equal to 0. Is it clear?
Yes, ma'am.
There will be no change. If I take derivative of a constant, that will be equal to 0. So I'm putting that value 0 to the left, and in place of P1t, I'm putting P bar. I'm using equation number 3. In place of P1t, I'm putting P bar, and in the left-hand side, I'm putting 0. So as I do so, I get the value for P bar, which is given by this one. Thus, P1t is equal to A bar minus B bar by A1 plus B1, equation number 4, is a solution of 3 and is called a particular solution. Okay, so P bar is one of the solutions of PT, since it is the equilibrium price. So P1t is equal to A bar minus B bar divided by A1 plus B1 is a solution of 3 and is called particular solution. Is it clear?
Ma'am, why are we calling one of the solution?
Because when you are considering the price is varying, okay? For the commodity X1, the price is varying across time. So it is one of the solution. Equilibrium price is one of the values. P1 may be, say, 10 rupees, 5 rupees, 200 rupees, okay? 50 rupees, 52. So all possible values we can have from the market when the price starts fluctuating over time. So in this period, maybe, in this month, price per kg of a particular commodity may be 102. And in the next month, because of many reasons, it can be 110. Next to next month, it can be 112. Next to next month, it can be, 107. So the things will go on like this. Okay. So at every price will change. Among these prices, one of the price is a market clearing price, and that price is the equilibrium price. Yes.
Ma'am, so here when we are talking about PE or P bar, we are talking about it from the market clearing sense and not the intertemporal sense.
It is also in intertemporal sense because we will derive the time path for PT only. Okay. So I think you are Kritika.
Yes, ma'am.
So you asked this kind of question for Higgs-Samuelson framework too. Okay, last day I forgot to clarify. In case of Higgs and Samuelson, the equilibrium value was given by GT by 1 minus C. Okay, so remember that when we are deriving the time path, we are deriving the time path for YT. We are not deriving the time path for YT plus 1 or YT plus 2. or yt minus 1 or yt minus 8. We are deriving the time path for yt. In the similar way, here we are deriving the time path for pt. pt is moving up, moving down, So we are deriving the time path for the time component t, where t is continuous or discrete in nature. So when we will talk about, if the equilibrium value is gt by 1 minus c, and we derive the time path for yt, naturally, always it will take a particular value.
Yes, ma'am, for that
Take
specific
a
period.
specific value. Yeah, because
Yes, ma'am,
deriving
understood.
the time path for yt. In the similar way, here too, actually, we are deriving the time path for PT. It is moving up, moving down, etc. So this is the Word file, so I'll be not able to put any matter here. So suppose I'm considering the cyclical movement of price. And here we will consider this slide. Okay. So in this entire time path, okay, I'm not understanding what is the problem. I wanted to write PT. It's not allowing me to write, I don't know why. Okay, so I wanted to write PT. So when it is coming, converging, etc., ultimately it is merging with the equilibrium price. So in this entire time path, one of the solutions is the equilibrium solution, isn't it?
Yes, ma'am.
For rest of the students, some students had questioned why it is one of the solutions. One of the solution because, equilibrium is also a particular price. Okay, so price is moving up, moving down, etc. However, it can take the equilibrium value too. So for a series of possibility, one of the possibility is the price is the market clearing price. So we can mention P bar as one of the solutions in the entire range of movement of PT. Is it understandable?
Ma'am, in the previous Higgs-Samuelson model, ma'am, it was GT by 1 minus beta. So 1 minus C. So ma'am, here the equilibrium solution was dependent on T. So ma'am, the equilibrium itself is moving.
Why the equilibrium will
Ma'am, because GT will change over time because it is dependent on time.
it
Earlier,
will change over time. I didn't get, T is time, you know. I am
ma'am,
I am sitting at this time period, So we are trying to forecast, or we are trying to predict what will be the movement of price or rate of interest for future days. What will be the path? Okay, so it is a matter of prediction or forecasting. So sitting at 2021, I like to predict what will be the nature of price in coming 10 years, or what will be the nature of national income in coming 10 years. So this is the purpose of time series analysis, okay? Time-based analysis or dynamic analysis, okay? So when we are considering this kind of forecasting or prediction for price variable, for income variable, for inflation or unemployment, okay? So I can have, along with my flexible path, I can have one equilibrium value which is given by GT by 1 minus small c, or GT by S, or whatever. Okay, so it does not indicate it is fluctuating in that sense, I am considering 2020 as the base, and on the basis of that base, I am predicting the whole pathway of the price. So my focus is on price or income or investment or savings function, etc., etc. I can find out time path of so many things. Okay. So in that time path calculation, if I have the equilibrium value carrying T, that is indicating, the expenditure of that period only, G of 2020. Okay, so it is not that when you are predicting the price for coming 10 years, you will consider GT, GT plus 1, GT plus 2. It's not like that. Okay, so 2020 G you have to consider.
Okay, ma'am, got it.
Okay, so I think I can proceed further. Is it okay?
Yes, ma'am.
Okay. So let's now, so PI part is done. A particular solution part is done. It is a particular solution among all possible solutions, which is the equilibrium solution, which is the market clearing solution. Let's now derive the complementary function. For that, we have to consider equation 3 without the constant term. That means you have to consider the homogeneous form of the equation. Okay, we will consider the homogeneous form of equation number 3. So let's check equation number 3 quickly. So if I do not consider this constant part, I have to consider only this part multiplied with alpha. Okay. Okay, so I'm doing that. I'm not considering the constant part, rather I'm considering the part which is a function or which is related to P1T. The solution of 5 is the complementary function. If I can solve for 5, that will give us the complementary function. Now to derive the complementary function, we have to consider a trial solution. As you know, you have to consider a trial solution. In case of difference equation, we considered a b to the power t as the trial solution. Whereas in case of differential equation, we consider the economic variable, say P1T, or it can be YT, it can be UT, it can be inflation rate, it can be anything. The economic variable is equal to constant into e to the power mt, e to the power mt. So the principle for solving the differential equation when the issue of complementary function is appearing, you need to consider the thing in this way. Okay. So actually for the solvability purpose, we consider the expressions in different format. In case of algebra, we will not consider the exponential kind of thing because, we will not apply calculus. Here, we are considering the exponential expression. We will be able to apply calculus and very easily we will be able to discuss the matter of convergence, divergence, etc. So these are the trial solutions, and we consider the trial solution which will give us the better solvability conditions. That's all. So let's try P1T is equal to a e to the power mt as the trial solution. Now, the expression is dp by dt is equal to this. So if pt is equal to a e to the power mt, what will be the value for dp dt? If the expression is pt is equal to a e to the power mt, what will be the value for dp dt?
A e to the power mt into m.
A e to the power mt into m. That is the solution. dp dt will be a e to the power m2 in mt into m. Okay, so the left hand side I am writing a e to the power mt into m. I'm doing nothing, I'm taking the derivative of this. Actually I have to put the matter in equation number 5. Okay, so I'm trying to find out the relevant expressions, that's all. The left hand side is dp by dt. So I have to take the derivative of p, and that is becoming a e to the power mt into m minus alpha into a1 plus b1. In place of p to pt, I am putting a e to the power mt. So the expression is a e to the power mt into m is equal to minus alpha a1 plus b1 into a e to the power mt. Now we can cancel a e to the power mt from both sides, and that gives us m is equal to minus alpha into a1 plus b1. Therefore, the trial solution can be rewritten as P1t is equal to a e to the power minus alpha into a1 plus b1 into t. So please tell me whether equation 6 is understandable. Starting from 5, how we are getting 6? Please check the steps once again. Is this okay to all of you?
Yes, ma'am.
Once
Yes.
we set this solution, this complementary function, a e to the power minus alpha a1 plus b1 into t, we will add the pi part with the cf part to generate the time path of price. So the solution to 3 is the sum of 4 and 6. 4 is the pi, this one, and 6 is the complementary function. So adding the particular integral with the complementary function, the time path can be written as P1t is equal to a bar minus b bar by a1 plus b1 plus a e to the power minus alpha into a1 plus b1 into t. Now equation number 7 is perfect apart from the fact that capital A is still unknown. Now to find out the solution of capital A, we set t is equal to 0. So A is solved using the initial condition. Using the initial condition, we can derive the value of A. So please find out the value of A. Set t is equal to 0 and find out the value of A.
Ma'am, as we are denoting t is equal to 0, so in the left hand side, we will write p10 like in place of t0.
Yes.
Yeah, then the value of a will be p10 minus a bar minus b bar divided by a1 plus b1.
Very good. And that is, nothing but P1 naught minus P bar. Isn't it? Look at the P bar value. It's all
Yes,
right.
ma'am. Yes, ma'am.
So in case of difference equation also you got the same thing. Pt minus Pe or Yt minus Ye. This was the...
Yes, ma'am.
So you are getting the same thing, only the style is a bit different. Okay. So at t is equal to 0, 7 times P10 is equal to a bar minus b bar by a1 plus b1 plus a, and which gives us this value. A is equal to P1 naught minus a bar minus b bar by a1 plus b1. this value is nothing but P bar. So A is nothing but P1 naught minus P bar. Okay, the similar kind of thing we got, in case of difference equation framework. So we are rewriting equation number 7. We are writing the full equation for the time path. Okay, so equation number 7 can be finally rewritten as P1t is equal to A bar minus B bar by A1 plus B1 plus, in place of A, P1 naught minus P bar, or you can write P1 naught minus A bar minus B bar by A1 plus B1 into e to the power minus alpha into A1 plus B1 into T. So please check equation number 9 once again. And if anyone has any doubt in equation number 9, please ask me.
No, ma'am, it is fine.
Ma'am, could you please scroll up for a second? I couldn't copy equation 7.
Would you please ask the question once again?
Ma'am, could you please scroll up for a second? I couldn't copy equation 7.
Equation 7, okay.
Yes, ma'am, thank you. Thank you, ma'am.
Okay. So once we get equation number 9, in the next step, we will try to understand whether the equilibrium is stable or not. This kind of analysis is coming, whether equilibrium is stable or not. Okay, so this thing is coming. Now equilibrium will be stable, you have the idea, if P1t moves towards this value, this is the P bar, P1t moves towards P bar as t tends to infinity. As t tends to infinity. If as t tends to infinity, this price moves towards this value, in that case, equilibrium will be dynamically stable. However, for that matter, we need this entire part will move towards 0 as t tends to infinity. This entire part will move towards 0 as t tends to infinity. Is it agreeable? From equation number 9, the requirement for convergence.
Yes, ma'am.
Repeat. Are you understanding, or should I repeat it once again?
Ma'am, can I repeat once again?
Okay, so expression 9 is fine with all of you?
Yes, ma'am.
In the next step, we will try to present the stability requirement. Okay, now looking at this equation, what we are finding that equilibrium will be dynamically stable if this P1t moves towards A bar minus B bar by A1 plus B1. This is nothing but P bar. So P1t moves towards P bar as t tends to infinity. The stability requirement is as t tends to infinity, P1t will move towards P bar, or move towards A bar minus B bar divided by A1 plus B1. Now to satisfy this condition, what we need that as t tends to infinity, this entire second part in the right hand side, that should move towards 0. As t tends to infinity, the second term in the right hand side, that should move towards 0, that we want. Are you getting my point now?
Yes, ma'am. Thank you, ma'am.
Okay. Now, can anyone tell me when the second expression can move towards 0? Look, here, somebody wanted to say something, yes?
P1 not is tending towards the A bar minus B bar by A1 plus B1. And
I didn't get your point. Just would you please clarify once again?
ma'am,
When
if
the second term will move towards 0, that I am asking. When the second term will move towards 0, that I am asking.
if
Ma'am,
P1
alpha A1 plus B1 greater than 0.
Alpha A1 plus B1?
Greater than 0.
Alpha A1 plus B1 greater than 0. That means he wants to say something regarding the element in the power. Alpha into A1 plus B1 should be greater than 0. He is telling that. Now look at this equation, equation number 9. This equation number 9 can be rewritten as P1T is equal to A bar minus B bar by A1 plus B1. That is the first part as it is, plus this entire part that within the bracket we can keep as numerator, and we can bring the e to the power alpha into A1 plus B1 into T in the denominator. We can do this because it is e to the power minus something. So I can write it as 1 upon e. So that I'll do. Okay. So this thing I'll do. I'll bring e to the power alpha into A1 plus B1 into T in the denominator. Okay. Now, as you know, who are you who told the condition should be positive?
Ma'am, Ion.
Ion. As Ion told us, you know, if this alpha into A1 plus B1 is positive, in that case, as t tends to infinity, this entire element is becoming infinity kind of thing. So it is e to the power infinity, e to the power infinity. Now, e is a positive mathematical constant. So if I consider the power infinity of a positive mathematical constant, the entire denominator is moving towards infinity. E to the power infinity is moving towards infinity. So, you know, if the denominator of this entire expression moves towards infinity, the entire expression will move towards 0. If the denominator moves towards infinity, that means it is something by infinity. So the second expression will move towards 0. However, if alpha into A1 plus B1 is minus something, it will be 1 by e to the power something. Okay, 1 by e to the power something in the denominator. Okay, so in that case, the denominator will move towards 0. So that this you will get this expression divided by 0. So this part will move towards infinity. Okay, so Ion rightly pointed that if alpha into A1 plus B1 is positive, the second term on the right hand side of equation 10 tends to 0 as t tends to infinity. From the above, it follows that limit t tending towards infinity P1t will be equal to A bar minus B bar by A1 plus B1 then. Okay, so from the above, it follows that as t tends to infinity, the price in the limiting sense will move towards equilibrium if and only if this value is positive. Thus, the positivity of alpha into A1 plus B1 is both necessary and sufficient for the stability of P1T. This is both the necessary and sufficient conditions, that is, if the equilibrium is stable, you will get alpha into A1 plus B1 is positive. Alternatively, if alpha into A1 plus B1 is positive, in that case, you will get the time path is stable, that the time path is converging. Okay? So please tell me whether you are understanding all this logic here up to this, whether you are understanding up to this. Any question? Yes?
Ma'am, alpha into A to the A1 plus B1 is greater than 0. ওই লজিকটা না বুঝতে পারলাম এই জায়গাটা।
তুমি এখানে দেখতে পেয়েছো তো এক্সপ্রেশনটা e to the power alpha into A1 plus B1 into T?
হ্যাঁ ম্যাম, ওটা ইনফিনিট হয়ে গেলে তাহলে ওই প্রোগ্রামটা 0 হয়ে যাচ্ছে, 1 বাই ইনফিনিট হয়ে যাচ্ছে।
So tell me, what is the expression? The expression for exponential, what is that expression? E to the power?
Alpha.
So today there is some problem, I think. Just no. Just I'm closing the thing, okay? E to the power alpha into this is the expression. This entire expression, are you agreeing? Okay. E to the power infinity. Okay. So, and if you consider e to the power infinity, is this value moving towards the entire expression, where you have the denominator like this, here you have one expression divided by e to the power infinity itself is moving towards infinity. Is it right? So you are getting something divided by e to the power infinity. So is this value is moving towards 0? This you are getting? Okay. আর যদি এটা নেগেটিভ হয়ে যেত, okay? So we will get something here, then in the denominator, this kind of expression. Okay. Now 1 upon infinity, since it is very large value, that is moving towards 0 itself. So this entire expression, something divided by 0 is moving towards infinity.
Hi, ma'am.
Okay. So in that case, the second part is moving towards infinity rather than moving towards 0 as t tends to infinity. Okay. So that will be absolutely a divergent time path. Okay. Divergent time path. So the necessary and sufficient condition to generate a convergent time path or to have a dynamic stability should be alpha into A1 plus B1 greater than 0. The condition is alpha into A1 plus B1 is greater than 0. Okay, so this is both necessary and sufficient condition for stability or convergence. Otherwise, the path will be divergent. Otherwise, the path will be divergent. Okay. So we can plot, in this axis, we are considering basically time, and along the vertical axis, I'm considering P1t. Okay, I'll be not able to put t, so please do it on your own. Put t here. Time I am measuring along the horizontal axis, and the price I am measuring along the vertical axis. Okay, so I have marked an equilibrium price which should be positive. Equilibrium should be a positive price. So A bar minus B bar. So you can put the notations A bar minus B bar divided by A1 plus B1. So that is the equilibrium value. So I can start from this point below equilibrium depending on from where we are starting the initial price. So it will converge like this. When alpha into A1 plus B1 is positive, it will converge like this. Or alternatively, this can be my starting point. So in that case, it is converging like this. This is the equilibrium one. A bar minus B bar divided by A1 plus B1. We are measuring T along the horizontal axis and price along the vertical axis. And here, please look at the matter. We should not consider a step function. Here, the curves are continuous in nature. The curves are continuous in nature because we are considering the price which is differentiable, which is continuous, with respect to time. So you will not get the step function. Your time is a continuous variable here. So you will get this kind of time path when your alpha into A1 plus B1 is positive. Otherwise, starting from this, you will diverge, or starting from this position, you will diverge. Okay? So So in a single diagram also, you may put the matter like this, or actually this is the equilibrium price. This is one possibility. This is another possibility. Here, the initial price starting from this position. Here, this position. So this kind of time path you will get if alpha into just here. Okay. So this is the equilibrium price. This is PT. This is PT. So this is P naught. Okay, so this is the idea. This is the idea. Okay, so one more thing I'd like to add. The above diagram may be explained as follows. From 9 or 10, it follows that at t is equal to 0, P1 t is equal to P1 naught, and the deviation of P1 t from this equilibrium value approaches 0 as t increases. Okay, but it does so at a decreasing rate. So what we are finding, asymptotically it is marching. Asymptotically it is marching. Okay, I mentioned that I'll not explicitly bring the second order derivative d square p by dt square here, because that will change the entire nature of the discussion. That will bring the second order matter in the analysis. However, when I am using the limiting sense as t is moving towards infinity, in case of first derivative, this limiting concept is capturing that slowly it is merging with the equilibrium price. Slowly it is merging with the equilibrium price. Speed of adjustment that will continuously fall as it is continuously converging towards equilibrium. So both the time paths are asymptotic in nature. These are merging asymptotically with the equilibrium price. Okay, so please add one more point. The time path okay, so this is that. Any question? Is it all? Yes.
For the stability condition, alpha is always positive. So ultimately, it comes down to the slopes of the individual curves. Like supply curve has to be, the slope has to be greater than that of demand.
So A1 and the nature of A1 and B1 will determine whether it is positive or whether it is negative. Okay?
Yes, ma'am. Yes, ma'am.
So whether it is slowly moved towards equilibrium or it will diverge from the equilibrium.
Ma'am, in this diagram on the right, are the two curves diverging parallelly?
Diverging parallelly with what? I didn't understand your question.
Ma'am, are the two curves diverging parallelly?
Actually, there is a single curve in reality. Either your starting point is above the equilibrium or your starting point is below the equilibrium. So you will not get both the points simultaneously, isn't it? Either this
Yes.
will be your starting point or this will be your starting point. You are not getting, you know, both the points simultaneously. You are not getting both the points simultaneously. You are getting one at a time. So there is no question of considering them parallel, non-parallel. All these issues are not emerging at all. The two possibilities I merged in a single diagram. That's all. However, it will be one at a time. Okay. Any other question? So this is all about the derivation of the time path using the first order differential equation framework. Next, we will go for second order differential equation. We will go for a market model using price expectations, and in that case explicitly I'll bring the second order derivative. Okay, so explicitly I'll bring the issue that, you know, where the price is increasing at an increasing rate, etc. So in the earlier model, both the demand and supply are taken to be functions of the current price P alone. But sometimes buyers and sellers may consider not only the current price, but also on the price trend prevailing at the market. But also the price trend prevailing at the time. Okay? You have some knowledge about the price trend for this particular commodity or service. So while you are trying to set the price on 2021, you are keeping the price trend starting from, say, 2015. So for the last 5 years, you are keeping the trend in your mind, and then only you are setting the price. So it's a complicated matter, you know. So market economics, when we go through the perfectly competitive market, it seems to be very, very simple construct, you know. There is a demand equation, there is a supply equation, price will be like this, you know. If demand curve shifts to this direction, this will happen. Supply curve shifts to this direction, this will happen. As a very simple kind of things. You know. However, if you try to really understand the market mechanism, you have to understand all these dynamics actually are there in the system. So while we are trying to fix the price of garments, say this year, so we are following the trend, you know, for this kind of design, this can be the maximum price. For this variety, this can be the maximum one. You know. Or what is the nature of customers, or for whom actually you are basically designing or producing the commodity. So what is the trend of their behavior? All these things are coming in the analysis. So, you know, if you look at the text, so while setting the price, we are not concentrating on demand and supply aspects only. Rather, we are looking at the what is the price trend in last 20 years for this commodity. Okay. In the bond market, in the share market, everywhere, these things happen. Apart from the commodity market, you know, there are bonds market. Okay. And in that market too, in the share market too, the things happen in this way. We'll look at the price trend for the last few years. So that may be 20 years, that may be 10 years, you know, that may be 50 years. So in the continuous time context, okay, just a minute. This price trend is likely to lead them at certain expectations regarding the price level in future. This in turn leads to influence their demand and supply decisions. Okay. So in the continuous time context, the price trend information is to be found primarily using the two derivatives, dp/dt, how it is changing, indicating whether the price is increasing or not, price is increasing or decreasing. So you will get some idea. And d square p by dt square, indicating whether the price is increasing at an increasing rate or increasing at a decreasing rate or decreasing at an increasing rate or decreasing at a decreasing rate. Okay. So this second order derivative will give us the rate, where if it increases, whether the rate is increasing or decreasing. If it is decreasing, which we are getting from the first order condition, then whether it is decreasing at an increasing rate or decreasing rate. So I think all of you are happy. Now you are getting the second derivative explicitly in your analysis, okay, which will be able to capture the speed of adjustment of price mechanism. Any question?
Ma'am, is constant rate also, can it also use the constant rate?
What rate?
Constant rate, can dp by dt2 also be like constant?
Concerned rate, or what you are telling, please write in the chat box.
Ma'am, constant rate.
Constant rate, ma'am, she's mentioned.
Constant rate, okay, constant rate. I'm not talking, generally we will, when we present the thing, we consider increasing or decreasing. Yes, it can be the constant rate. In that case, the second derivative will be equal to 0.
Okay, ma'am. Yes.
Thus, the demand and supply equations are written as, I'm complicating the matter a bit, QD, which is equal to D as a function of PT. This was there in the earlier framework. Then I am bringing P prime T and P double prime T. That is the first derivative of the price, which will indicate whether price is increasing or decreasing. And the second derivative, so if it is increasing, what is the rate? If it is decreasing, what is the rate? Similarly, in the supply function too, I am bringing P prime T and P double prime T along with PT. Got it?
Yes, ma'am.
Yes. Okay. So considering the linear demand and supply equations, again, we will consider the linear functional format. This can be presented as alpha minus beta P plus M P prime plus N P double prime. We are considering the betas in this way. Alpha and beta, two parameters are positive. We are not telling anything about the signs of M and N because price may increase, price may fall, So M can be positive, M can be negative. Similarly for N, it can be at increasing rate, it can be at decreasing rate. Therefore, we are not mentioning anything about the signs of M and N. The supply equation I'm writing as minus gamma plus delta P. However, you can write gamma plus delta P as well. That will not change any essence of this framework. Okay, so minus gamma plus delta P plus say U into P prime plus V into P double prime. So here also I'm marking the signs of the two parameters gamma and delta. However, I'm not mentioning anything about u and v because it may move to any direction. Here, alpha, beta, gamma, delta, m, n, u, v are the parameters of the model. Okay, so there are 8 parameters in the model, 8 parameters. Okay. Now, one by one, we will indicate the meaning of positive m, negative n, m, etc. If m greater than 0, this implies buyers expect that price to go up in future. If m is positive, buyers expect that the price will go up in future and hence the present demand increases. I'll start to store because price will go up in future. If it is not a perishable commodity, I'll start to stock the commodity because price will go up in future. Alternatively, if m is less than 0, buyers expect that price will go down in future and hence the present demand falls. Okay, next. Inclusion of n indicates buyer's decision depends on the rate of change of price and so on. Okay, so buyer's decision also depends on when they are expecting price increases, whether the price will increase at an increasing rate or price will increase at a decreasing rate. Now, if they expect price will increase in future, they will start to make a stock. Now, if they expect the price will increase at increasing rate, in that case, they will go for more stock. And if they expect price will increase, however, at a decreasing rate, in that case, they will go for lesser stock. Okay, so all these things will happen. And if you really think about the real life cases, actually our decision depends on all these issues. Now we are expecting again a lockdown at least for 5 to 7 days. And many of us have started to buy, some commodities which we can store for a long period. So all these things happen. So not only price, because of many different kinds of shocks, which we expect, our buying or selling decisions change. Okay, so here we are talking about the price. There may be different types of external shocks in the system. For simply, we assume demand depends on expected future prices while supply is not. So to keep the model simpler, we will consider, okay, for simplicity, we will assume to begin with, demand depends on these expected future prices while supply will not. However, once I complete this model, you have to do on your own when suppliers also depend on U and V. Okay, that is what will be the future price, what will be the rate of change in future price, that you will accommodate and derive all the results that I'll derive now. Okay, so I'm keeping the supply equation very simple. QS is equal to minus gamma plus delta P. This I am not using at this moment. However, the demand equation, I am keeping all these elements. So equating the demand with supply, we get this kind of equation: alpha minus beta P plus NP prime plus NP double prime is equal to minus gamma plus delta P. okay, or NP double prime plus NP prime minus beta plus delta P is equal to minus alpha plus gamma. Okay, we can divide both sides by n and we can have this kind of, expression. P double prime plus m by n p prime minus beta plus delta by n p is equal to minus alpha plus gamma by n, which is equation number 3. And I hope everybody is understanding, because of presence of p double prime, this is a second order differential equation in P. Second order differential equation in P. Any question, any query regarding equation number 3? Now, if you consider the entire supply equation, here the values will be a little bit different. You will have some, from the supply side, you will have some element, UP double prime, UP prime, VP double prime. So all these coefficients will be adjusted accordingly.
Ma'am, for U and V, write that.
U and V?
Ma'am, we consider two other parameters, U and V too, so we won't be writing that when we are equating demand with supply.
I think I already mentioned, to keep the model simple, I am considering that suppliers do not consider the expected future prices at this moment. I am bringing the expectation only for the demanders, not for the suppliers at this moment. And this will be your homework to complete the thing, redo this entire exercise when the supply decision will also depend on expectations. Okay?
Okay, ma'am.
Okay. So once we get the second order differential equation, next step will be to find out PI, complementary function, etc. So the easiest task is to find out PI. To derive PI, particular integral or particular solution, we consider the intertemporal equilibrium price PE. We consider the intertemporal equilibrium price PE. Now for the equilibrium price, what are the values of P double prime and P prime?
0.
0?
0.
Everybody? Will it
Yes,
be?
ma'am.
So when we are considering PT is equal to PE or P bar, equilibrium price, both the first order and the second order derivatives will be equal to 0. So set this equal to 0, this equal to 0, minus and minus will be cancelled. So P will be equal to this divided by this. So 1 upon n will be cancelled, and therefore the equilibrium price will be alpha plus gamma by beta plus delta, which is equation number 4. Okay. It represents a, I think, please don't write this term, because there may be some problem. You may think I am talking about the convergence. So simply write this is the intertemporal equilibrium price. Just write this is actually I wanted to mean at equilibrium price remains stationary. Okay, so let me put the thing in this way. Okay. Any question? Next. The complementary function is given by PC. For complementary function, I am using the notation C, PC. PC is given by A1 e to the power R1t plus A2 e to the power R2t. So here I have to bring the two roots, R1 and R2. When I am going for the second order differential equations, you have some idea from your second order difference equation. It will be root based analysis. Okay. So the complementary function is written as P or PC is equal to A1 e to the power R1t plus A2 e to the power R2t. So in the previous case, it was simply A e to the power mt kind of thing. However, when we are going for this kind of second order differential equation, actually there is an underlying quadratic characteristic equation in it. There is an underlying quadratic characteristic equation in it, generating two characteristic roots R1 and R2. So this is the idea. Whenever you are going for the second order difference or differential equation, actually you have a quadratic characteristic equation in it. Okay, a quadratic characteristic equation is implicit in this kind of second order difference or differential equation framework. So it will be a root based analysis, characteristic root based analysis. Okay. So the complementary function is given by A1 e to the power R1t plus A2 e to the power R2t, where R1 and R2 are two roots given by, then you know, minus b plus minus root over b square minus 4ac by 2a. So please look at equation number 3. Okay, look at equation number 3, and I hope you will be able to write down this thing. And by the way, when we consider this kind of characteristic equation, etc., that we do always for the homogeneous form, because now we are in the trial solution or in the path to derive the complementary function. So whenever the issue of complementary function is coming in the analysis, we have to concentrate only on the homogeneous form. So the constant term in the right hand side is not there in our analysis anymore when we are deriving the complementary function. Okay, so remember that when we are talking about characteristic equation, deriving the characteristic roots, those things will be done only for the homogeneous form of equation number 3. Okay, so I'll tell you to write down the values for the two roots R1 and R2 from this equation. You consider the homogeneous form of equation number 3 and write down the values of the two roots so that I can check whether my signs or every value is fine or not. Please let me know what are the values once you write down the values.
Ma'am, I've written it down.
Okay. For other students, you have written?
Ma'am, I have written it.
Okay. So anyone, please tell me what are your values so I can check the things.
Ma'am, half in third brackets minus m by n plus minus root over m by n whole square plus 4 into b plus delta by n.
Okay, the same thing I got, or I presented as equation number 6. So everybody please check whether you are getting this or not.
Yes, ma'am.
Okay. So once you get the root values, there are three possibilities. Roots are real and distinct. Okay, depending on the discriminant. Roots are real, however repeated. Okay, so all these possibilities are coming. Could you complete up to equation number 6? Everybody? So if you complete or understand up to equation number 6, please concentrate on this equation. Please concentrate on equation number 5. Okay, better. First you write down the time path. First you write down the time path.
Ma'am, can you please tell how we got the PE?
How we?
Got the PE.
I didn't get you.
Ma'am, can you show the PE value again?
Value of?
PE.
Ma'am,
Yes,
PE.
ma'am.
Ma'am, she's talking about the intertemporal, like the particular solution.
Okay.
No, ma'am, you don't need to scroll that high. I saw it. Yes, it's correct. It was equation number 4 of that. Yes. Yes. Yes, ma'am. Done. Thank you.
Okay. So, before going further, would you please write down the structure of the time path? Okay, PT.
I'm written.
This value. This part. Is it fine to all of you?
Yes, ma'am.
This is the structure of the time path. Okay. Now, if this is the structure of the time path, the stability of entire time path will depend on the values and the nature of this R1 and R2. Are you getting that point? This is a constant. A1 and A2, these are also constants. So as t tends to infinity, PT will merge towards this if this entire part is equal to 0. As t tends to infinity, PT will move towards this PE if this A1 e to the power R1t plus A2 e to the power R2t, this part moves towards 0. Okay. Now, to have this part, the second part, this entire part, this part will move towards 0. What is the requirement regarding the signs of R1 and R2?
Negative.
Negative? Everybody negative?
Yes, ma'am.
Yes, ma'am.
Because in that case, we will have 1 by e to the power R1t, 1 by e to the power R2t. So as t tends to infinity, e to the power R1t in the denominator will move towards infinity. So, you know, A1 by infinity, A2 by infinity. So both the terms will move towards 0. So very good. So if R1 and R2, you know, these are, both of them are negative, in that case, the time path will be stable or the time path will be convergent. Alternatively, if the roots are positive, in that case, you know, the time path will be divergent. The time path will be divergent. As long as the roots are real, the time path will be always monotonic. However, if the roots are complex conjugates, the time path will be oscillatory. So that part is common, you know, both for the difference and differential equation. Remember that as long as roots are real, the time path will be monotonic in nature. Otherwise, the time path will be, you know, oscillatory. Okay, so this is the matter. So monotonic, and for the monotonic and oscillatory, you have to look at the matter whether the roots are real or oscillatory. For the convergence, you need that both R1 and R2 will be negative. For all other possibilities, the time path will be divergent. Okay. So roots are real. 3 possibilities as I mentioned. Roots are real and distinct. Look at the discriminant. Now you understand how to, you know, mark whether the roots are real, distinct, whether the roots are complex conjugates, you know, all these things. So roots are real and distinct if m by n whole square greater than minus 4 into beta plus delta by n. Accordingly, the general solution given by this, equation number 7. Okay, so এটা ওখানে চলে গেছে। Okay, if R1 and R2 both are negative, as I mentioned, or you know, you yourself mentioned that, in that case, PT will move towards PE as t tends to infinity. Okay, so this is the construct. Now, if roots are real and repeated, what are the values of the roots? If the roots are real and repeated,
minus m by 2n.
Minus m by 2n. Minus m by 2n, because this part is equal to 0 then. So if the roots are, you know, the roots are repeated real roots, the value is minus m by n by 2, m by 2n, minus m by 2n. So as long as both m and n are positive, in that case, the value will be negative. So both the roots will be negative and you will have the convergent time path. However, if m and n are like that, so that this entire term is positive, in that case, you will have divergent time path. Okay. So R is equal to minus m by 2n. Accordingly, the general solution can be presented in this format. It can be presented in this format by equation number 8. If minus mt by 2n is negative, in that case, the path will be convergent. Under both the circumstances, real distinct and real repeated, the time path will be monotonic in nature. Because as long as the roots are real, the time path will be monotonic in nature, and convergence depends on whether both the roots are negative or not. If both the roots are negative, then only you will have convergent time path. Otherwise, you will have divergent time path of the concerned variable. Okay, so please take note of the fact that, note, as long as the roots are real, we will have monotonic time path. We will have monotonic time path of PT. Monotonic time path of PT. Okay. So I'll stop here. Tomorrow I'll discuss the case of complex conjugate roots.
Ma'am, can you show page 5 and page 3 again?
5. This equation.
Ma'am, a bit down. Page 5.
This equation number 5 or what?
Page 5. Look a bit down.
I'm not understanding. Would anyone please let me know what?
She wants page 5.
Page 5. Yes, this is page 5.
Yes, ma'am. And can you show page 3 once again?
Page 3.
Page 3, yes.
This page.
Yes, ma'am. Ma'am, after equation 10.
This is there.
Like just move a bit down after.
For the rest, please check the recording. You will have everything in the recording. I'm sending you the slides, so and the entire recording, so you will get the things from there. Still, if you have any problem, definitely I'll try in the next